Everyone has something that motivates them. For some people, it's money. For some, it may be recognition, and others, maybe chocolate. If you're one of my research animals, it's the beloved Fruit Loop. They absolutely love these as treats. They're easy for them to put in their mouth, and most importantly, they're packed with sugar. In our lab, we study the brain chemical dopamine. Dopamine is involved in movement, most notably implicated in Parkinson's disease, motivation, and reward. We study dopamine in relation to learning and memory tasks. Our rats learn to run in a maze, and if they complete the task correctly, they receive a food reward at the end. We study and record when dopamine is released as the rats are completing this task. Look, he's even smiling. Dopamine helps activate the learning centers in the brain. So if dopamine is released as you're learning something, it will help you remember that information at a later date. For example, I had a chemistry professor on the very first day of class do an intense reaction with lots of flames and smoke. He then explained how and why this chemical reaction took place. This reaction was done just using regular tap water and sodium. After he explained how this reaction worked, I'll never forget exactly how those electrons are moved in that reaction. As likely as this reaction was taking place, dopamine was being released in my brain. Of course, since I don't have any of our lab's electrodes placed in my brain, we won't know for sure. On the left is a picture of the electrodes we build in our lab. The electrode end consists of a single strand of carbon fiber. It's about 1/10 the diameter of a strand of human hair. We then implant these electrodes in freely moving animals and record when dopamine is released as they complete maze tasks. As you can see, the rat brain is very small. It's about the size of a nickel, and the area of the brain that we're trying to reach is about the size of a pea. We implant these electrodes in an area of the brain that's known to have a high number of dopamine neurons. One of my main hobbies is photography, so for the background of my talk, I thought I would take you all on a tour of my lab by way of my photography. These are just a few of the things we use in our lab to help us record dopamine. So what can we do to increase dopamine in our brain? Exercise is a great way to increase dopamine. Exercise will increase dopamine release in your brain, as well as other neurochemicals, such as endorphins, which are the brain's natural painkillers. Eating properly is another great way to increase dopamine. Specifically, eating foods rich in tyrosine, which is a precursor to dopamine, will help increase available dopamine in the brain. Foods rich in tyrosine include things such as avocados, almonds, and bananas. Another great way to release dopamine is doing something rewarding to you. This can be something as easy as checking something off your to-do list, or perhaps volunteering at a community center. And of course, one of my personal favorite ways to increase dopamine is sex. Sex releases many beneficial chemicals in the brain in addition to dopamine, such as oxytocin, which is implicated in human bonding, serotonin, which relates to happiness and a feeling of well-being, and norepinephrine, which increases alertness. So how can we use this information? Professors can develop new and exciting ways to deliver information to students. It doesn't have to be as exciting as involving flames and explosions like my chemistry professor. It can be as simple as having students do a hands-on experience, or perhaps using the students as props to explain a difficult concept. Professors, get away from the traditional monologue lectures. It'll be more rewarding for the professors and will stimulate the students to promote long-term learning. Let's get those dopamine neurons firing. Thank you.